Hi everyone, and welcome to the MCP workshop series, where we break down everything you need to know to build intelligent AI agents for the AEC industry. This series is structured around 4 pillars: data, AI, API, and MCP. Each one is independent, but together they form the foundation of any intelligent system. We'll cover the theory behind each pillar and then move into hands-on implementation, where we build a full MCP system from scratch, step by step, with real code and real Autodesk data. Today, we start with the first pillar, data. Let's get the most important point out of the way. AI is entirely dependent on data. There is no way around it. The quality of AI system is directly proportional to the quality of your data. If your data is messy, your model will be messy. And this is especially relevant in AEC, where data is often incomplete, heterogeneous, and scattered across disconnected systems. You might have a Revit model that says one thing, a spreadsheet that says another, and a PDF plan set that contradicts both. So, before we talk about AI, before we talk about APIs or MCP, we need to understand what data we're working with and how to evaluate it. There are 6 main categories of data that matter in our industry: numeric, text, audio, visual or 2D, video, and geometric or 3D. Each one behaves differently, is processed differently, and comes with its own set of challenges. Let's go through them quickly. Numeric data is information expressed as numbers for measurement or calculation. In AEC, this includes cost data, planning data, telemetry from sensors, and resource utilization metrics. This is often the easiest type of data to work with, because it's inherently structured, but it still needs to be accurate and consistent. Text data is information conveyed through sequences of characters or words. Think site reports, contract documents, standards, and project specifications. Text is rich in context, but hard to process automatically. A sentence like "the beam should be reinforced" carries meaning that's obvious to a human, but requires natural language processing for a machine to interpret. Audio data is information captured as variations in sound over time. This covers meeting recordings, voice notes, noise monitoring, and safety briefings on site. Audio is temporal and dense. A 1-hour recording contains far more information than most people realize, and extracting useful data from it requires transcription, filtering, and context. Visual, or 2D data, is represented as a flat grid of pixels. This includes 2D CAD drawings, PDF plan sets, photographs, and scanned sketches. Video takes this further by adding the dimension of time. Drone footage, progress images, site videos, and training recordings all fall into this category. Both are powerful sources of information, but they're unstructured by nature and require computer vision techniques to extract meaning. Geometric, or 3D data, is defined by points or shapes in 3-dimensional space. This is where Revit and BIM models live, along with GIS models, LiDAR scans, and point clouds. This is arguably the most valuable type of data in AEC, but it's also the most complex. A BIM model isn't just geometry. It's geometry plus metadata, relationships, and context. Now that we know what types of data exist, the next question is, how do we evaluate whether our data is any good? There are 4 key attributes. First, accuracy. Does the data correctly reflect real-world facts? An accurate dataset hits the target. A precise but inaccurate dataset clustered tightly but in the wrong place. In AEC, this could be a model that shows dimensions consistently, but they're all 5 centimeters off from the actual site. Second, consistency. Is the data represented identically across systems? If one system calls an element A01 cube with dimensions in meters, and another one calls it cube A1 with dimensions in decimeters, you have a consistency problem. Same object, different representations. Third, completeness. Is all required data captured with no necessary parts missing? An incomplete dataset is like a puzzle with missing pieces. You might be able to guess what goes there, but your AI system can't. Fourth, accessibility. Can authorized users actually locate, retrieve, and use the data when they need it? Data locked behind permissions, buried in legacy systems, or stored in formats nobody can read is effectively invisible. It's also important to distinguish between internal and external data quality. Internal data quality is about evaluating the data contained in your own systems. You have full control over this. You set the rules, the format, the naming conventions. External quality is about how your data interfaces with external systems. Here, you need to comply with industry standards and partner specifications. You don't control the format, you adapt to it. Another critical distinction is structured versus unstructured data. Structured data is organized in a defined format. Tables, columns, fields, Excel spreadsheets, SQL databases, sensor measurements, easy to query and connect across systems. Unstructured data has no fixed format. Emails, PDFs, images, videos, conversations, scan plans. It's difficult to analyze automatically, but often rich in context. The good news is that unstructured data can be transformed into structured elements. You can use automatic document classification, object detection, or entity recognition to extract names, places, and numbers from free text. Two more concepts to cover before we wrap up. Data quantity is a balancing act. Too little data limits analysis and reliability. Too much data makes management and access complex. A database with 1 million records can be less useful than a sample of 100,000 that covers all observed situations. Quantity should always be evaluated relative to coverage and intended use. Noise is the other side of the coin. Noise refers to erroneous, inconsistent, or random values that don't represent observed reality. It hides real trends and reduces reliability. Sources include data entry errors, miscalibrated sensors, incomplete records, and byte format conversions. Noise never disappears completely, but it can be reduced through verification, outlier detection, and, more importantly, domain expertise. Finally, let's look at the AEC Data Pipeline. This is the 5-stage process that takes raw data and makes it usable. Collection, evaluation, structuring, cleaning, and enrichment. Each stage builds on the previous one, and skipping any of them means your downstream AI systems will suffer. This pipeline is what connects the data pillar to everything else we'll cover in this series. Clean, structured, enriched data is what feeds the AI models, flows through the APIs, and gets exposed via MCP. That's our first pillar covered. Data is the foundation everything else builds on. Next time, we'll move to the second pillar, AI. We'll look at what types of AI exist, how they map to human capabilities, and where they're being applied in AEC right now. Leave your questions in the comments, and I'll see you for the next one.